Hello there everyone, welcome to Edupedia World 9th Grade Computer Applications video lecture series. I am Upeka Vandibona and here we go again with another object orientation principle, abstraction. And this is our last episode of this lecture series. Now, inheritance is just the beginning. We need to go beyond the simple inheritance to a level of flexibility and extensibility. Take a look at this example that we have created in a previous episode. We designed it so that the duplicate code is kept to a minimum level, and we have overridden the methods that we think should have subclass specific implementations. We have made it nice and flexible from a polymorphic perspective because we can design animal using programs with animal arguments so that any animal subtype, including those we never imagined at the time we wrote our code, can be passed in and used at runtime. We have put the common protocol for all the animals in the animal superclass, the 4 methods that we want the world to know all the animals have: make noise, eat, sleep, and roam. And we are ready to start making new wolves. Therefore, we know that we can have a wolf reference to a wolf object like as in this illustration, and also we know that we can have an animal reference to a dog object. We covered that part in the polymorphism episode. But here is where it gets weird. Animal reference to an animal object. It is, by the way, legal, but there is no sense in creating an animal reference to an animal object. There is no point of creating such a thing. The animal object. I mean, what shape is it? What color is it? The size, number of legs? What are the instance variable values? You could not answer those questions. So there is no proper use in creating an animal object. Some classes just should not be instantiated. But how do we deal with this? We need an animal class for inheritance and polymorphism, but we want programmers to instantiate only the less abstract subclasses of class animal, not animal itself. We want tiger objects, lion objects, wolf objects, but not animal objects. Fortunately, there's a simple way to prevent a class from being instantiated. In other words, to stop anyone from saying new on that type. By marking the class as abstract, the compiler will stop any code anywhere from ever creating an instance of that type. You can still use the abstract type as a reference type, to use it as a polymorphic argument or return type, or to make a polymorphic array. In fact, that's a big part of why you have the abstract class in the first place. When you're designing your class inheritance structure, you have to decide which classes are abstract and which classes are concrete. Concrete classes are the classes that are specific enough to be instantiated. In other words, it's okay to make objects of that type. Making a class abstract is easy, putting the keyword abstract before the class declaration as in this example. Now, I mentioned earlier the compiler won't let you to instantiate an abstract class. An abstract class means that nobody can ever make a new instance of that class. You can still use the abstract class as a declared reference type for the purpose of polymorphism, but you don't have to worry about somebody making objects of that type. The compiler guarantees it. Now, in this example source code, we made the K9 class as abstract. Abstract public class K9 extends animal. Now, in the make K9 class, we are trying to create an object with the K9 class. Let's see what would happen in there. Inside the go method, we first create the K9 reference variable, and in the next statement, we are assigning a new dog object for that reference variable. And that is okay because you can always assign a subclass object to a superclass reference even if the superclass is abstract. So we are allowed to do this. The problem comes in the next statement because in that statement we are trying to assign a new K9 object for the K9 reference variable. As the class K9 is marked as abstract, the compiler will not let you to do that. At the compile time, you will get an error saying K9 is abstract, cannot be instantiated. Now what you have to understand is an abstract class has virtually no use, no value, no purpose in life unless it is extended. And also with an abstract class, the guys doing the work at runtime are the instances of the subclasses of your abstract class. Good. Now we are trying to identify what are the abstract classes and what are the concrete classes in a design. A class that's not abstract is called a concrete class. In the animal inheritance tree, like as you see in here, in the animal inheritance tree, we make animal, canine, feline abstract, and that leaves hippo, wolf, dog, tiger, lion, and cat as the concrete subclasses. There is no point of creating animal objects or feline objects or canine objects because we cannot assign values to the instance variable. But we can create lion objects, cat objects, tiger objects, hippo objects, wolf objects, and dog objects because we can assign values to the instance variables. For example, we can assign a name to the dog, we can assign a name to the wolf, and we can say the color of the dog, we can say the color of the wolf. Therefore, they are concrete classes, but animal, canine, and feline are abstract classes. Okay, now we know about abstract classes. Now we are going to talk about abstract methods. Beside classes, you can mark methods abstract too. Now the abstract class means the class must be extended. An abstract method means the method must be overridden. You might decide that some behaviors in an abstract class don't make any sense unless you are implemented by a more specific subclass. In other words, you can't think of any generic method implementation that could possibly be useful for subclasses. For example, let's think about a generic method like as eat. Now, because you have already decided that there isn't any code that would make sense in the abstract method, you won't put anything in the method body. So an abstract method has no method body. So no curly braces, just end the declaration with a semicolon. Now remember, if you declare an abstract method in a class, you must mark the class abstract as well. You can't have an abstract method in a non-abstract class. So remember to put the keyword abstract in the class also. And the other thing I want to mention, in an abstract class, you can have both abstract and non-abstract methods. The mix of them are allowed in an abstract class. And if you have abstract methods in your class, you have to implement all of these abstract methods. Now, implementing an abstract method is just like overriding a method. An abstract method don't have a body, they exist solely for the polymorphism. That means the first concrete class in the inheritance tree must implement all the abstract methods. And here is the tricky part. You can, however, pass the implementation just by being abstract yourself. For example, if both animal and canine are abstract and both have abstract methods, class canine does not have to implement the abstract methods of the animal class. But as soon as we get to the first concrete subclass, for example like dog, the subclass must implement all of the abstract methods from both animal and canine. In earlier, I mentioned that abstract class can have both abstract methods and non-abstract methods. Therefore, if canine could implement an abstract method from the animal class, the dog didn't have to implement that. But if canine says nothing about the abstract method from animal class, dog has to implement all of the animal's abstract methods. Now, when we say you must implement the abstract method, that means you must provide a method body. And that means you must create a non-abstract method in your class with the same method signature and a return type that is compatible with the declared return type of the abstract method. In Java, we use the term method signature for the method name and the arguments. Now, what you put in the method is up to you. All Java cares about is that the method is there in your concrete subclass. And that's all what we got here in this episode. With this episode, we are going to end up our lecture series, 9th grade computer applications. This lecture series is to learn fundamentals and basics. For more advanced stuff, you can always look into our Edupedia channel. Thank you for watching and stay tuned on with Edupedia World. This video brought to you by edupediaworld.com. Watch more from our website.